Okay, so find the area bounded by x equals negative y minus 1 times y minus 3. So the first thing that I would do is just sketch a graph of what this looks like. So the easiest way to do it is to actually turn your page on side, but I can't do that. So I'm going to turn me on side, and I'm going to start graphing this. So it's going to have an intercept here, an intercept here, and then because it's negative, it's got to finish down. Yeah? Does that seem right to you? Yep, no, that seems right to me too. Okay, so find the area bounded by the curve and the y-axis. So we want this yellow area in here. So we're going to integrate from 1 up to 3. We're not integrating on terms of x here, we're integrating in terms of y. Like that. Now, what are you going to do? Multiply it through, sure. Y squared minus 4y plus 3. Take the negative out front, or do you want to multiply the negative in? Multiply it in, okay. So you had, I don't know. So now you take the antiderivative. So negative y cubed over 3 plus 2y squared minus 3y. And we're going to find the area between 1 and 3. So you substitute negative 3 cubed over 3 plus 2 times 3 squared minus 3 times 3 minus cubed over 3 plus 2 times 1 squared minus 3 times 1. And then you reach for your calculator and you get an answer. Well, you don't really need a calculator for this. 3 times 3 is 9 times 3 is 27. Throw a negative in front of it. Negative 27 divided by 3 is negative 9. 9 times 2 is 18. 3 times 3 is 9. Hey, look! 0. That's exciting. Okay. And then over here we got negative 1/3 plus 2 wholes minus 3. So you got negative 1, negative 1 1/3. Positive 1 1/3. I mean, and we are happy with that answer, because if you look at the because if you look at it, Mr. App, it's on the right-hand side of the y-axis. It's a positive area, right? Yeah? How's that? Complicated? No. Technical? Yeah, a little bit. Okay, so somebody made an observation yesterday, but I shut him down. Mr. App, why can't I just do this and get the answer and recognize that it's doing the same thing? This would be something that I would do quietly on my calculator and get an answer. It is, yeah, it's the same thing because they're inverses of each other, right? It's the same area. No, exactly the same answer. Because they're exactly the same shape. Well, you don't have to do any of it graphing. I'm just making the point. If I wanted to check my answer, this is what I would do. No, well, unless you make a big long-winded statement by saying, you know, blah blah blah. These are inverses, blah blah blah. So they contain the same area. So blah blah blah. Like if you want to make that big leading paragraph statement first, fine, probably would. But how many of us are willing to write a good paragraph before you go and do the work? Yeah, okay. Okay, so summary. This is important. This is huge. And I looked at this when I got these notes from a friend of mine. I was like, wow, that's like, this is the bomb. So the area under the curve, the net area under the curve is the antiderivative from a to b of f of x dx. So we got a nice picture, and we've got a nice antiderivative statement. Mr. F, I don't want to do the area under the curve. I want to do the area next to the y-axis. Notice how it changes. Oh yeah, you're integrating with respect to y now, and you're using y coordinates d and c to do the question, not the x coordinates, because the x coordinates are 0 there, right? Okay. Region C. If I want to do the area between two curves, I take the higher one and I minus it from the lower one, and I integrate it between the two intersection points. If there are multiple sets of intersections, what has to happen? Yeah, each one must be done separately. Okay? Yeah, so let's say f of x, let's say it does this. I want both of the areas. And I'm going from a, this is a good question. This is a great question. How would I find that area? Pardon me? Yeah, but you need to be very careful about how you do the question. Yeah, it's f of x minus g of x for the first one. And it's, no, it's g of x minus, g is higher, sorry, g minus f for the first one. Plus f minus g of f. So you gotta. That's a nice no calculator multiple choice question right there, like that. How would you find the total shaded area? Is it this one minus this one? This one, you know what I mean? Like, because I betcha, I can't predict what's on the AP exam. I can look at 23 exams over the last little while where they released some of it. You might see this, right? You know, that would be a suck-in answer. You might see, oh, okay, I've got to suck, you know, like all sorts of crazy talk here. So that's why I'm using that Barron's guide, because those people used to make AP exams. You might as well buy the book from the expert, right? You know, here's a good study guide. You don't think I'm lying to you when I'm saying this is good. I'm not making it up. Anyways. And then region C, region D. So if I want the area between two functions that are expressed as y values, then I integrate from C to D of f of y minus g of y. So here it's the farther higher minus lower, more right minus more left, or not as right. You know what I mean? More positive. General comments. notice that A and B are on the x-axis and C and D are on the y-axis. When using formulas involving f of x, you must solve for y. When solving formulas involving f of y, you must solve for x. So you gotta watch out. Look at the region and decide which way to slice. Vertical slices are dx, or to the x-axis. Horizontal slices are dy, or to the y-axis. Remember, if using horizontal slices, write relations in the form x equals. So, I don't know if we can color code all this together, but C and D are on the y-axis. F of y, dy, like these, all of this goes together. Notice A and B on their x-axis. You know, I don't know. You start doing it and it'll happen. If finding total area, sometimes it's necessary to break up integrals. Don't do it all at once, right? So if I ask for total area, you got to remember that anything below the x-axis has to be found separately and then flipped up, right? Made positive. So the example of that would be to say, and a friend of mine's doing it a slightly different way. She's saying, I'm going to find the area between A and B, and that's a positive amount. And then I'm going to find the area. Notice how she's finding the area from B to C. She's doing it backwards, so when you flip, it'll flip up. The way I asked you guys to do it was to do the area from B to C, and then throw the absolute value around it. We're going to get the same answer. It's just a question of technique. So, yeah, we're talking about total area, not net area. Net area, I would just do the antiderivative from A to C and be done with it. Right? Net area, net, I would just do this. Total, you have to stop at B. Have to. Okay. Are we good? No? Okay, we're gonna start day 3. I don't think we'll get it all done. You don't have this class today, you have a math contest today. Pardon me? Yeah, it's 45 minutes, but I'll let you work on some homework, that assignment, whatever. Okay, so I'm going to stop.